This next example will expose your customers on how to create more complicated animations with this larger machine. We're not going to take this animation down to the end level of detail by having things like the jaws open up and close things. We're going to take a little bit more of a simplistic fashion, but the goal is to get the gripper to go from point A to somewhere over here just to pick up something. The key thing to learn in this example here is how to use the Assembly Navigator to speed selection. So what we're going to do is first I recommend going to the Assembly Navigator and expanding the second and third subassemblies. That way you have a nice fast way of picking things. Alright, here's the problem we have is whoever built the assembly here forgot to include these little feet in the highlighted subassembly. They put them in a completely different subassembly, and while it sounded good at the time, it doesn't lend itself to good motion because we want these sliders to go along with this transport mechanism. Alright, so let's begin with the rigid group command, and what we're going to do is pick the entire kind of plunger mechanism, and we'll just pick the whole thing from the Assembly Navigator. Now normally you might not want everything in there. You might want some control over like the grippers and whatnot. We're just going to take the default here, the entire subassembly, and move it as one large rigid group. In another example, we'll see how we've separated these things out. Next, I want this transport mechanism to slide up and down and back and forth. So we're going to pick these things, and that's going to allow this transport to go back and forth, but the plunger to go up and down on it. Next, let's go ahead and pick maybe everything in this subassembly here. Now, if you pick the entire subassembly, it's going to take these out of your current rigid group, so you don't want that. So we're just going to use the Shift key, pick everything that's in here, except what was selected there. And when you're picking with the Shift key that way, it omitted these parts for you automatically. Then we're going to pick these two little feet on either side, and that's going to include everything in that transport slider mechanism that we need to have move back and forth and facilitate movement back and forth and allow this to go up and down. So hit the apply button, and last but not least, we want everything in this third subassembly. So if you pick the entire subassembly, it's going to take these feet out of there, just kind of the behavior of the command here. So, but if you pick the Shift key and pick everything inside the subassembly, it will omit things that are already in another subassembly. So just keep that in mind when you're going through this. Just blindly picking at the subassembly level may not necessarily be a good thing. Then when we hit the OK button, we can inspect our rigid groups, and we have 1, 2, 3, 4 of them. But if you want to see them in color, which I recommend always showing, is how the rigid groups are in its own independent color. I consider that step to be done. Let's go ahead and apply sliders. Again, we're not going to worry about the little jaws here and the rotating mechanism here. So let's fix the magenta part first. So as you would imagine, we're going to pick the fixed slider joint and then pick the entire rigid group and hit apply. Then we want maybe the green part to slide back and forth on that magenta colored part, so we'll pick the sliding joint. We'll pick the green rigid group as its first item, the magenta color one as its second. Now, what do you want this thing to transport across, or which vector do you want it to go along in? You could pick an edge here, and that's a perfectly valid selection. Or you could pick this triad right on the screen. Now, whoever built the model built this thing orthogonal to the world, so we could use these vectors here to pick our direction. Key thing here is the arrow that now displays on the screen for the vector arrow. That's going to define what the positive direction is for that particular joint. So when you key in 1,000 later on, it'll go back deeper into the screen. We don't want that. We want 1,000 to be sort of to the right. So you can either double click the arrowhead, or you can click the reverse direction button on the vector dialog. Now, when you're helping customers and they key in 50 and it goes the opposite direction, the first thing you should check is the joint, make sure it's actually defined in positive, the way the customer thinks the positive direction is going to be. Hit apply, and next but not least is this little red slider part. It wants to go back and forth. on the green mechanism, so the second input will be the green mechanism. And the vector will be along the, the y-axis. Now, positive is going to the left. You probably want positive to the right. That way, when we key in, say, 1,000 or 1,200 or whatever, it's going to go to the right, as you would expect. 0 to a 1,200 is in a positive direction, so we need to flip that direction in a positive manner. Next, let's have the plunger go up and down. So we want the blue thing to go up and down on that salmon-colored thing. And there's several ways that you can specify the direction. You could pick an edge on a part, like I have highlighted. You could pick the vector here, or pick a flat piece or a flat plate, and it gets the normal off of that. Several ways of doing this here. The reason I didn't use that pick the face type method is I had so many small faces on here, it might have been a little harder than just pick the axis. Plus, it's good to show you all the different ways that you have to do that. Now, which way do you want the plunge positive to be? Down being positive or up being positive? Normally up is positive, but I am going to I'm going to leave that. So when we key in our value, we want to enter down with a negative when we get to the actual motor itself. That's probably good enough. Let's go ahead and take that take those inputs. Now is a good time to validate your joints by the move ridge group command. Pick the blue part and the center ball and just drag things around and see if everything is sort of holding together. If you forgot to put your fixed joint on, that magenta color part will be flying around as well. That'd be the indication to lock it down. Also, things seem to be reacting and moving very, very as expected. All right, step 2 is done. Now it's time to add some motors. We're going to spend more time getting sequence of operations defined, but right now let's just get some basic motors going and see how this thing reacts to that. So we've been using speed motors in the previous examples. This one will be using a position motor. A position motor is an intermittent motor. Goes a certain distance or a certain speed or a certain time and then stops. You could have it start up and do it again, but it has a defined start and a stop, whereas a speed motor, it just runs continuous like a fan. Position motor, perfect example for an actuator, what we have here. So we apply a position motor to a joint in the first one. Maybe we want this green thing to go back and forth, so you pick the joint, and then you can enter in some values. So what you're entering in here, start time, end time, and a distance. We know the distance, it's 1200, I measured it earlier, but if you don't, you can change that value a little later on if you want to, if you enter in the wrong value. And the system will calculate what that speed happens to be. This is probably not the best of examples. When you buy an actuator, you know what the speed is, but you want the end time or the start time or whatever calculated for you. So basically, there are 3 variables here. You enter 2, and the system is going to calculate the third one. The system is going to calculate speed. The system could also have calculated the end time, also calculated the distance. So if we hit the end time, what I would have to key in is the speed and the distance. That's probably a little bit more natural because you buy a motor with a certain speed, you know how far you want it to go, and I don't really care how long it takes to get there. But for example, it doesn't really matter what you key in here because this is just a short training example here. I'm going to let the thing run for a second, and we're going to get it to go 1200 millimeters. And it is going to figure out what the speed is, which just happens to be 1200. Hit the apply button, and the next motor we're going to add is one to get the slider to go back and forth, the salmon colored part and that green part. Same process as before. What do you want the system to figure out, the speed, the end time, or the distance? I'm just going to take the defaults here. I'll enter the distance of 1200, again because I measured it earlier and I know what it happens to be, and take those inputs. Last but not least, we want the plunger to plunge. Now recall that I had the positive in the up direction, so if you want it to go down, you've got to enter it in a negative. And I'm going to enter it in a distance of minus 300 because I want this thing to plunge down into the conveyor and pick something up. All right, this is good enough for right now. The beauty with this system here is so fast and so easy to edit things. It's faster just to throw something up on the screen and then tweak it and beat it into submission later than worrying about all these precise values here. Now that that's done, you're ready to hit the play button. And not only does it move back and forth, but it plunges at the same time. So we actually have 3 motors happening at the same time. We're not going to worry about getting the sequence of operations correct yet. This is good enough for this example here. The key things that you learned are position motors, using the assembly navigator to speed selections.